concept exam number 7 for advanced algebra. We're going to start off by looking at question number 1, which tested concept number 9, direct variation. It says, if y equals 166 when x equals 83, what is y when x equals 23? The way I would suggest that you solve this is to set up a proportion, or you could just basically set up the ratio y over x, which is what we use with direct variations anyway. So we'll do a y, 166 over x, 83, equals a y, which is unknown this time, over x, 23. Algebraically, we just want to multiply both sides by 23 to isolate y. So we'd have y equals 23 times 166 over 83. I put that in a calculator and got 46. So my answer for number 1 is 46. Alright, number 2, concept 10, linear modeling. Says a 3-mile cab ride costs $3. A 6-mile cab ride costs $4.80. We need to find a linear equation that models the cost C as a function of the distance D. When they say cost C as a function of D, that means we should have C equals some stuff over here that has a D in it. Okay? That's the basic format of our answer. Models the cost C as a function of the distance D means C is going to equal some stuff with a D in it. So let's see what else they've given us. They've given us basically data, some information. They've given us a 3-mile cab ride costs $3. So that means when cost is that means when the distance is 3, the cost is $3. And we also have another data value here. When the distance is 6 miles, the cost is $4.80. 4.8. I'm asked to find a linear equation. Anytime I'm asked to write an equation of a line, I need to remind myself that I just need 2 things to do that. One thing is a slope, and one thing is a point. I've got a couple points, so I'm okay with that. I just need to go find the slope using the slope formula. So we'll take y2 minus y1 over x2 minus x1. We get 1.8 divided by 3, which is 0.6. So I know right now that my slope is 0.6. If I can find my y-intercept, I can write a nice linear function or linear equation. So y is equal to 0.6 d plus some other value that I don't know. We usually call it b, and y equals mx plus b, so we'll just go ahead and call it b now. How do I figure out what this b value is? Anybody? How do I figure out what the b value is here? B. Say that again. Oh, you want to do it the other way? Just plug it into point slope and then work it backwards? Solve it back? Let's do it that way. That's not a bad idea. So the suggestion was to use the point slope form, which is y minus y1 equals slope times x minus x1, and then solve it. So we could do that. Y minus y1 would be y minus 3 if we use this first point, equals the slope 0.6 times x minus 3. But we don't want to use x's and y's. What do we want to use for this problem? C's and d's. And I have x and y in this column, which represent the c's and d's from my problem. So the x is a c, and the y is a d. Let's go ahead and clean that up. D minus 3 equals 0.6. Let's distribute here. 0.6 times x is 0.6x. What's 0.6 times 3? Pardon? 1.8? Yeah, we just did that division over here, so it should go the same way. And then add the 3 to both sides. So d is equal to, actually I copied that as an x, it needs to be a c. D is equal to 0.6 c minus 1.8 plus 3, which is 1.2. So our function, our linear function, d equals 0.6c plus 1.2. Any questions there? This next problem was arguably the hardest problem on the exam. What's the vertex of this function? What kind of function is this? Absolute value, right? And when we graph an absolute value function, we expect what kind of a shape? A V shape. So when I'm talking about the vertex, what am I talking about? It's this point right down here at the bottom, right? It's the key point we would use to graph. So to find that key point, I need to get this equation into a certain format so I can recognize what that vertex is going to be. So what do I need to do to force that into that format? You guys remember? This is one of the harder ones. We haven't seen it in a little while. I need to get this -3 out of the way. I need to see x plus or minus some value, and then I'll know exactly what to do with the x coordinate. And the y coordinate is going to be a 4, a -4. So how can I get this -3 out of the way? Yeah, well, what we did learn that we could turn things around, right? Subtraction, we could change all the signs inside an absolute value, and it doesn't change the value of what's going on there, because the absolute value just is looking at the 2 minus 3x is the same as 3x minus 2. It doesn't matter because the absolute value is going to give us the positive of that anyway. Now I got to get the 3 out of the way. Remember, we factored that out, took the 3 out here, and what would come next inside the absolute value? X minus what? 2/3. And then we have the -4. Now I should be able to look in basically these two locations and determine what the vertex is. What's the vertex? It's going to be positive 2/3, comma, -4. That's our vertex. Concept 12, we're graphing linear and absolute value inequalities. This first question just says write an equation, or the equation, for the translation of y equals absolute value of x. We should recognize y equals absolute value of x as being this first graph here, and then it's translated up to this second graph that's on the diagram. So what do they have to do to move this graph up? What do they have to do to the equation? Plus 4 outside the absolute value. So we're just going to take the original graph and add 4 to it, move every point up 4. And that'll do it. That's the answer to number 4. Y equals absolute value of x minus 5 and then -4. I got way too many lines on this one. We should recognize right away that what we're graphing is not a line. We're actually graphing an absolute value which should have a V shape. Which way is this V going to open? Up. And what's the vertex of the V? 5, -4. So the first thing I'd want to do is find 5, -4. So if I go 1, 2, 3, 4, 5, -4, 1, 2, 3, 4. I've noticed my vertex is kind of on the edge of the graph, so I might want to change the scale so this fits a little better. So instead of going by 1s, I'm going to indicate that I'm going to go by 2s here. And I'll go ahead and go by 2s on the y-axis also, just so that fits better. Oh, thanks. It's not going to hurt us too bad, but it kind of looks bad when you make that kind of an error. So let's go 5 to the right, 2, 4, 6, 5's right in the middle, and then down 4, 2, 4. We should have a vertex right here. Tell me about the sides. How am I going to find a point for the sides? Yeah, it's basically up 1 over 1. We've got a slope of 1 here. So if I go up 1 over 1, I could go through this point. If I go up 1 over 1, I could go through this point. Same thing going to the right. I'll go through this point, and now I should be able to draw some sides. And there's my graph. Some of you guys went ahead and drew it down here, which was fine. 5, 1, 2, 3, 4. You just went ahead and graphed it off the scale, which makes it kind of hard to do this because you don't have any graph paper left to get that set up right, kind of guess on it. So I went ahead and gave you credit for that too. 6 was the hardest of the group. We've got not just that absolute value, but we're also having to deal with an inequality, the less than. Some of you guys did really well with that. Tell me about the absolute value. Which way does it open? Up. Where's its vertex? -2, -2. And then let's go ahead and find that vertex. -2, -2 is about right here. Tell me about the sides. What's their steepness? 1. So we go up 1 over 1, and we'll do that a couple times. It'll give us enough points to draw. And tell me about how these sides should be drawn. Why should they be dashed? Because it's strictly less than. There's no equals. So let's go ahead and dash in the sides here. And then we've got to figure out the shading. And how do we figure out the shading on this one? Pick a point not on the line. Somebody pick a point not on the sides. -1, -1. Definitely not on any of the sides. Let's substitute that in and see what we get. If we put -1 in for y and -1 in for x, let's see what kind of statement we get. -1 is less than. -1 plus 2 is 1. Oh, that's 1 -1. Well, let's go ahead and use that one then. Let's go ahead and use it anyway since we're almost there. 1 -1. So I need 1 plus 2. 1 plus 2 is 3. Absolute value of 3 is 3. Minus 2 is 1. Is -1 less than 1? True or false? That's true, which means the true side's the side where the green is. So we're going to shade this whole side out here. So all that gets shaded in. Questions on this? So concept 13, linear systems, it says basically solve. So on question 7, how do you want to begin? I think everybody probably did the same thing. Yeah, just subtract the equations. 5x minus 5x zeros out. -1y minus a -3y should be what? 2y equals, and then 5 minus 15 should be -10. So y turns out to be -5. I don't want to stop here. Some of you guys stopped too soon. I want to find the x value that actually goes with that. If I put a -5 back in this equation, I get 5x minus a -5 equals 5. Well, some of you guys are going to solve this by inspection. 5x plus 5 equals 5. What does x have to be? 0. 0 plus 5 would be 5, so x has to be 0. So my solution is the point 0, -5. X is 0 and y is -5, so that one's done. And then off to number 8 here. How do you want to begin that one? This one was slightly more difficult. Multiply the top, that's what you did, multiply the top by 3 and the bottom by 5. That's a choice we can choose to make. Multiply the top by 3 and the bottom by 5. Did some of you guys multiply the top by 2 and the bottom by 3? Yeah, that's another choice you could choose to make. Let's go ahead and do this one. 3 times 5 is 15x, plus 3 times 3 is 9y, equals, don't forget to multiply the 3 on both sides, the -18. On the second equation, we'll have a 15x minus 10y, and don't forget that right side is going to be a 20. Now what can we do? Subtract. 15x's minus 15x's zeros those out, eliminates them, that's good. 9y minus a -10y, be careful with that, is a 19y. A -18 minus 20 should be a -38. When we divide by 19, a -2 appears. Now we just need to find x. So let's go ahead and plug that into this equation. 3x minus 2 times -2 equals 4. 3x plus 4 equals 4. By inspection, what does x equal? 0 again. So we ended up with the point 0, -2 this time. And we have a solution. Any questions now?